Hello? Yes! And welcome to our Objective 8 notes for part 2 of Objective 8. Gosh, it's good to see y'all again. Objective 8 says, I can determine whether a relation is a function. Now, if you remember last time, we focused on identifying relations and the different types of relations. We talked about XY tables, mapping diagrams, coordinate planes. We talked about coordinate pairs. We talked about all those different ways to identify, to write relations. And now we're finally going to determine whether or not a relation is a function. And that's the basis of this objective. So first, let's start by defining a function. A function is a type of relation where each input, each x value, has one and only one output. Alright, so if I put in one value for x, I can only get one value for y. And what we're going to do today is we're going to walk through each of the different models that we talked about yesterday. And we're going to ask the critical question, basically, what we need to know. And then we're going to practice it. So we're going to start with an XY table here. So if presented as an XY table, the critical question to ask is, does the x value or input only occur one time? Alright, so looking at our examples here, it asks, identify if the following represents a function y or y not. So looking at letter A, my x value is -2, 0, 1, 3. I can tell right away then, since this is -2, 0, 1, 3, that this is a function. Why is this a function? Because the x values don't repeat. X values don't repeat. None of them occur more than once. There's -2, there's 0, there's 1, there's 3. No repeating. Looking at letter B, -3, -1, -1, 3. Is this a function? Look how -1 produces -2 and -1 produces 2. Is this a function? No. Why? -1 produces multiple outputs. Right? If -1 produces multiple outputs, we know right away then this is not a function. Remember, the definition of a function is that each input corresponds to one and only one output. Well, -1 in this case responds to -2 and +2. So this one then is not a function. Let's look at letter C. Input 1, 2, 1, 3, 2, 5, 4, 8. I know right away then function. No, it's not, because 1 produces multiple outputs. Since 1 produces multiple outputs, we know this is not a function. What about letter D? I have 1, 2, 5, 6. I have no repeating inputs, so this is a function. X values don't repeat. All right. Why don't you go ahead and try letter E and F? So go ahead and pause the video, try E and F on your own, and then we will check those together. Alright, let's see how we did here for E and F. Looking at letter E, I have x value 0, 2, 4, 6. Is that a function? Yes, indeed it is. The x values don't repeat. I have no repeating x values, therefore this represents a function. What about letter F here? -2, 0, 0, 4. Is this a function? No, because 0 produces 6 and -6. It produces multiple outputs. Since this produces multiple outputs, we know this is not a function. Alright, so that's XY tables. Raise your hand if you got any questions on XY tables. Otherwise, let's move on to mapping diagrams. The critical question to ask with the mapping diagram is, does each input or x value have only one arrow coming from it? Does each input or x value only have one arrow coming from it? Remember, in mapping diagrams, our inputs are identified on the left, our outputs on the right, and then the arrow connects the input to the output. So looking at our examples here, let's start with letter 2 here. Looking at letter A, -3, -1, 0, sorry about that. That's letter D now. Why'd that happen? Here we go. All right. looking at letter A, I got -3, -1, 0, 4. Each one only has one arrow coming from it. -3 goes to 7, -1 goes to 5, 0 goes to 3, 4 goes to 9. Is this a function then? Yes, it is. All right, each input only has one arrow coming from it. What about letter B? I have inputs of -10, -5, and 0. -10 goes to 20, -5 goes to 12, and 25. So I know right away then this is not a function. -5 creates multiple outputs. All right, looking at letter C, I have inputs of 1, 4, 7, 10. Each input only has one arrow going from it, so this is a function. Now notice letter C's 1 and 4 both go to the same output. That's okay. That's totally fine. We can't have multiple inputs, or we can't have one input going to multiple outputs, but we can have multiple inputs going to the same output. All right, so why don't you go ahead and try D, E, and F here. Go ahead and try those on your own. Pause the video, and then we will check those together. All right, let's see how we did. So looking at letter D, I see inputs of 0, 3, 6, 9. Each of them only has one arrow coming from it. 0 goes to 3, 3 goes to 5, 6 goes to 1, 9 goes to 3. So this is a function. Looking at letter E, 1 goes to 4, 7 goes to 11, 11 goes to 0, so this also is a function. Looking at letter F, 2 goes to 0, 5 goes to 0, 9 goes to 8, 14 goes to 8. Each input only has one arrow coming from it, so this is indeed a function. All three of those represented functions. Now what I would like you to try is I would like you to draw two mapping diagrams. I want the one on the left here to represent a function and the one on the right to not be a function, all right? Go ahead and try that. Does the one on the left, so make the one on the left represent a function, make the one on the right represents a relation that is not a function. Go ahead and pause the video, try that, and then we'll check those together. All right, so I'm going to draw a couple here. They won't necessarily be the same as yours by any means. All right, so let's say we have -2, 0, and 3. Let's say we have 4, 6, and 11. So the key here is that each input only connects to one output, and the order doesn't matter, nothing like that matters. We're just trying to draw something that is a function. Rather, on not a function, we need something else. So let's say we have, what numbers? I need a negative here probably. Let's do, why can't I erase this? Let's try -3, 0, and 4. Let's say that goes to 3, 5, 8, and 9, something like this. Let's make this -8 because I can't even understand what that says. All right, so let's say -8 goes to 3, that's great. 0 goes to 5, but 4 goes to 8 and 9. So this would not be a function then, because that 4 has one input creating multiple outputs. So obviously the function and non-function that you drew will be different than mine, guaranteed. However, that is the idea we're going for. If you're not sure whether or not you did it right, feel free to raise your hand. I'd be happy to come around and check to make sure that you have a good understanding of what constitutes a function and not a function in our mapping diagrams. All right, so let's try to move here. Let's try this again. All right, so moving down, there we go. Coordinate points. If presented as a coordinate point, the critical question to ask, does each x value only occur one time? All right, so let's look at these here. Identify the following coordinate if the coordinate points represent a function. All right, so we got 4, 2, 5, 7, 5, 12, 6, 15, 7, 21. Is that a function? No, it is not. Why is it not a function? Because 5, 7, 5, 12. One input producing multiple outputs. There we go. Looking at letter B. -1, 5, 0, 5, 1, 2, 2, 4, 3, 1. Is that a function? Yes, indeed. We don't have any repeating x values there. All right. I think at this point you guys probably got a plan. Why don't you go ahead and try C, D, E, and F on your own? Go ahead and pause the video, and then we can check those together. So go ahead and do C, D, E, and F on your own, and then we'll check those together. All right, let's see what we got here. Looking at letter C, I got 3, -4, 5, -6, 7, -8, 9, -10, 11, -16. Is that a function? Yes, indeed. Each x value only occurs once. Looking at letter D, 1, -5, 1, 0, 5, -5. Is that a function? No way, because 1, -5 and 1, 0. We have multiple outputs for the same input. Looking at letter E, -10, 4, -6, 3, -2, 2, 0, 3, 2, 4. I think that one checks out all right. That one is indeed a function. Looking at letter F, -3, 5, 1, 1, 2, 8, 2, 6, 3, 9. Is that a function? No way, Jose, because 2, 8, 2, 6, we have one input producing multiple outputs. All right, that's coordinate points. Let me know if you have any questions about those. Otherwise, let's move on to coordinate planes. And the key question to ask when we're looking at coordinate planes is, does the graph pass the vertical line test? Now, the vertical line test is really quite simple. If I move a vertical line across the graph, the vertical line should only touch one point of the graph at a time. So looking at letter A, imagine taking a vertical line and just sliding it right on across. If I slide that vertical line across, it only touches one point at a time, right? We'd have this one, this one, this one, this one, this one, that one. They only touch one point at a time. If that is the case, then yes, this is a function. However, look at letter B for a counterexample here. This vertical line, this vertical line, this vertical line. What happens here? We have 2 points that we touch, right? 2 points on the same vertical line. That means our x value produces multiple y values, right? Our input produces multiple outputs, which means this is not a function, right? Can we all see that? If that one value here, that one x value produces multiple y values, so that means this is not a function. All right, what about on full graphs, not just points? So looking at C, if I take a vertical line and split it any point here, yeah, that vertical line is only touching one point at a time, so this does represent a function. However, if I take a vertical line on D, notice right there, it touches here and here. It touches on the top and bottom of this shape. So is this a function? No, it is not. All right, why don't you go ahead and try E and F, determine real quick if this is or is not a function. Don't even need to pause the video. This should be something we can just look at and know. I'll give you 5 seconds. All right, E, does the E pass the vertical line test? Well, if I take a vertical line, for example, that y-axis, I can see right away. Boom, boom, touches multiple spots. This then is not a function. Looking at letter F, however, if I take a vertical line, I think this one checks out just fine. All of these spots would only touch one point. So yes, F is a function. All right, last task I'll have you do today. Go ahead, I would like you to draw something that represents a function on the left, something that represents a relation that is not a function on the right. Go ahead and pause the video, something that is a function on the left, not a function on the right. Pause the video and then we'll check it together. All right, let's see. So obviously your graphs can look much different from mine. Something that is a function, the key here is that it passes the vertical line test. So it could be something like this. Right, something that passes the vertical line test, each input is only going to have one output. Not a function, you could have drawn a lot of things. You could have drawn a square. That would not be a function because, this vertical line right here touches in multiple points. Right here touches in multiple points. You could have drawn a circle. You could have drawn all sorts of things. You could have drawn a swirly here. That'll work. A triangle wouldn't be a function because of the vertical line there. Any of those ideas will work. If you're not sure whether or not your function and not a function are good examples, raise your hand. I'd be happy to come around and check. All right, and that is going to end where we are today. So I'm going to draw not a function here. a nice little smiley face to end our lessons today. Go ahead and do your check for understanding. Link is posted up on the whiteboard. Check that up there. When you're done with that check for understanding, raise your hand. I'll be happy to come around and give you your practice problems, all right? So I will see you next time. Mr. Carter, signing off.